Hey everybody, welcome to Chapter 3, Section 5, Proving Lines Are Parallel. This section should feel a little familiar to you because it's basically going backwards from the previous sections. So in the previous sections, we learned about interior angles, exterior angles, all the types of angle relationships they were, alternate interior, exterior, things like that. And we defined all these properties that, all these angles were congruent or supplementary if they were in between parallel lines. So now this section is focused on going backwards. It's proving lines are parallel when you're given at least one of these type of angle relationships out there. So these right here are the postulates or theorems that are in this section, and they all are converse because, like I said, it's going backwards, and that's basically what converse means. So this is converse of corresponding angles postulate, and that basically says that if you have corresponding angles, then the line that are congruent, then the lines are parallel. And these other ones say essentially the same thing. If you have congruent alternate exterior angles, then you know your lines are parallel. If you have supplementary consecutive interior angles, or same side interior angles, then the lines are parallel. If you have congruent alternate interior angles, then your lines are parallel. And then this one should feel a little new. It's the perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. Meaning, if you have a perpendicular line going through two lines, and so by definition, a perpendicular line will form a right angle. So if it forms a right angle with both of them, then those lines are parallel. If one of these angles was a right angle, like 90 degrees, and the other one wasn't, then those lines aren't parallel. So it kind of makes sense given all these other ones. But yeah, so let's do example 1 here. Given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So, if angle 1 is congruent to angle 3, is it possible to prove that any of these lines are parallel? So I'm going to guess that we're going to see, can we prove that line A is parallel to line B, given that angle 1 and angle 3 are congruent? So if you look at lines A and B, angle 1 would be interior and angle 3 would be exterior, and they're on the same side of your transversal line here, making them corresponding angles. And so if corresponding angles are congruent, then you can use this here, corresponding angles, converse of corresponding angles postulate, stating that therefore your lines are parallel. And so in this case, lines A and B would be parallel. And that's basically all you need to know for this example, really. So let's look at example B. It's going to be down here. Measure of angle 1 equals 103 and measure of angle 4 equals 100. So let's see here. So if we're looking at angle 1 and angle 4, I'm going to ignore line B and just focus on lines A and C. So if 1's here and 4's there, that would make them alternate interior angles. And alternate interior angles should be congruent. So if we look at this, this example here, if you have alternate interior angles that are congruent, then your lines are parallel. But 103 is not the same thing as 100, obviously. So therefore, you cannot determine that these lines are parallel. There you go. If you need to see it written down, there it is. But I'm going to move on to example 2 because that's basically just exactly what I said. So here I have examples A through F. It says, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So let's look at example A here. Is angle 2 congruent to angle 8? Okay, so 2's here, 8's there. They would fall in between or on the interior of lines A and B. And so that would make them alternate interior angles. So if angle 2 is congruent to angle 8 and they're alternate interior angles, then by the alternate interior angle converse, that lines A and B would be parallel. Let's just skip to D since it's right there. If angle 1 is congruent to angle 15, can we tell if the lines are parallel? So angle 1 is here, angle 15 is there. This is on the exterior of transversal A, this is on the exterior of transversal B. They need to be on the exterior of the same transversal, so therefore this is not enough information to prove that A is parallel to B or L is parallel to M, because they're on different transversals. So ultimately this is all you need to say for your answer, that it's just not possible to prove lines are parallel. Looking at example B, angle 3 congruent to angle 11. Okay, if angle 3 was congruent to angle 11, that would mean we're going to use lines L and M. How do I know that? Well, they are bordering the transversal line A there, so that would mean I'd have to use L and M for my parallel lines, or to try and prove those. So let's see here. This would be an interior because it's in between L and M, and this would be exterior because it's on the outside of M. And so that would make these corresponding. One interior, one exterior. They're on the same side of the transversal. So yes, that is enough information to prove them parallel. So looking at example E, if angle 8 and 13 are supplementary, would that be enough to prove parallel lines? So far, the only angle pairs that we've learned about that can prove parallel lines are same side interior angles or consecutive interior angles. So are 8 and 13 consecutive interior angles? Yes, they are. They are both inside lines L and M. So yes, by the consecutive interior angles converse, lines L and M would be parallel. Alright, so angles 12 and 14. Here's 12, here's 14. So they're in opposite sides of the transversal line M. So that means I'm going to have to compare lines A and B. So let's see here. They would both be exterior. 12's exterior of A, 14's exterior of B. And so that would make these alternate exterior angles. And yes, if alternate exterior angles are congruent, then that's enough information to prove lines A and B are parallel. So angles 8 and 6 are congruent because they are vertical angles. But vertical angles are not one of these, postulates or theorems that we're learning about in this chapter. Vertical angles, but it doesn't matter that they're not from this chapter. Vertical angles are angles, that share a common vertex. And so you don't need parallel lines to have vertical angles. I only need two lines, B and L. Those are just intersecting lines there. So that is not enough information to prove that lines L and M or A and B are parallel. Next, I'm going to do a couple of solving examples. So basically, you're going to solve for the missing piece so that A is parallel to B. So you're kind of like assuming that they're parallel, or you're treating them as such. So like if lines A and B were parallel, then these would be alternate interior angles. So that means alternate interior angles are congruent. So I'll set these equal to each other and solve for x. Then I have to plug x back in to figure out what MRQ is, which would be MRQ. That would be this one right here. But since they're congruent, it technically doesn't matter which one you plug it back into, but so I'll plug it back into that one. Okay, whenever I'm solving problems like this with an x on each side and a constant on each side, I like to just get my x's all on one side, right? So I know 5x is smaller than 7x, so I'll choose to start with that. So I'll minus it over. And then on the same line, I will add 21 over to the other side. And, people can get confused solving problems like this, but I just think of it like this. I canceled one thing on the left, so that means I have to cancel one thing on the right as well. So that way, when I combine my like terms now, 7 plus 21 is 28, and 7x minus 5x is 2x. All I have left to do is just divide. So 2x divided by 2 cancels, and then 28 divided by 2 gives me 14. So if x equals 14, what is the measure of angle MRQ? So I'm going to say 5 times 14 plus 7 equals 77 degrees. So that's angle MRQ. Okay? So in example 5, I have 11x minus 25 and 7x plus 35. So if lines PQ and MN were parallel, that would make these alternate exterior angles, which are congruent. So just like the last one, I'm going to set these two equal to each other and solve, and then I got to plug it back into the one that says ZYN. So ZYN would be this one right here. So I see 7x is smaller than 11x, so I'll choose to subtract that over. That cancels one thing on the right hand side, so I need to cancel one thing on the left hand side by adding 25 over to where the 35 is. And so 11x minus 7x would give me 4x, and 35 plus 25 would give me 60. And so divide both sides by 4, and 60 divided by 4 is 15. And so if x equals 15, then measure of z angle ZYN is going to equal 7 times 15 plus 35. And so that's going to equal 140 degrees. And that's it for example 5. So this section is called proving lines parallel. And so sometimes you have to actually prove something to be true in this class. So geometry is a very proof-based course where it's like we give you all these properties of angles or different shapes, and then you pretty much kind of like assume them to be true, right? But you can't assume anything to be true, not in the world of math, unless it's proven to be so. So what we're going to do is going to give you small little examples for you to prove. So in this example right here, I'm going to try and prove theorem 3.5, which is the alternate exterior angles converse. And so it's going to be kind of like the other ones, but we're not going to do any math. We're just going to bring up like reasons and definitions. So proofs are kind of confusing, but they're supposed to have kind of a logical flow because this is like the logical component of this course. So it says, given angle 1 is congruent to angle 2, prove that lines L and M are parallel. So in geometry class, you'll have these, they're called two-column proofs. On the left, you have your statements, so the things that you are trying to prove, and then your reasons are, how do you know that's true? And so you're just supposed to kind of build your case here. So above it, I wrote these three properties of equality. Use them. You'll see them appear a lot, and you might be kind of familiar with them. So I just thought I'd put an example of each to kind of refamiliarize yourself. But you have something called the reflexive property that just says A equals A. It's just saying the same thing, but so it's very obvious. But yeah, that is the reflexive property of equality. The next is symmetric, and that says if A equals B, then B equals A. All right, so it's just like you can flip the order of the equal sign. It doesn't matter. And then the transitive. If A equals B and B equals C, then by the transitive property, A equals C. So those come up every now and then. So let's just jump right into this proof. The first statement you always write down is something that's given to you. You can have more than one thing given to you. In this example, we only have one thing given to us. And so our reason is it's given. And then you look at the picture and you try and like build your case. You're like, okay, so if angle 1 is congruent to angle 2, that's given. What else can I determine to be true? And so look at the picture. It's got an angle 3 there. So the next thing they wrote, sorry, I kind of skipped over it. Your proofs are generally given to you with some pieces missing, and we just ask the students to fill in the missing pieces. It's rare that you're given a completely blank two-column proof, unless you've gotten a whole lot of practice with them. But yeah, so back to this. How do we know that angles 2 and 3 are congruent? Well, if you look at them, those are vertical angles. And by definition, vertical angles are congruent. So that's all you need to say. The next thing brought up in our statement here is that, if angle 1 equals angle 2 and angle 2 equals angle 3, then the next thing to do is say, hey, angle 1 equals angle 3. And how do you know that? That's that transitive property. If A equals B and B equals C, then A equals C. So, if 1 equals 2 and 2 equals 3, then 1 equals 3. So that's a transitive property of equality. So what's the last thing we have yet to prove? Because we've proven all these angles here are congruent. The last thing you have left to prove is that lines L and M are parallel. So how do we ultimately know that lines L and M are parallel? Well, look at the last thing you just proved. We just proved angle 1 is congruent to angle 3. Those are corresponding angles, right? So if corresponding angles are congruent, then the lines are parallel. And that's pretty much how you prove that converse of the corresponding angles postulate right there. So yeah, proofs are a little weird, but that's basically all there is to it. So let's just go through another example right here, and it'll be a little bit longer. Instead of having A through D four lines, we have 5 lines now, A through E. So it says copy and complete the proof of theorem 3.6, which is the consecutive interior angles converse, okay? So it says that angles 1 and 2 are supplementary. Prove that line L is parallel to line M. So this first statement here is blank, but then it says given. What's given to you? That angle 1 and 2 are supplementary. So unfortunately, that's not enough to say, hey, this is my answer. I don't need to say anything else for the proof. I like to explain it like this. If you see more than one angle in the picture, like you see 3 angles here, we're going to talk about all 3 angles. So right now we just talked about these 2. So let's talk about angle 3 and how it relates to angles 1 and 2. So right here it says angles 2 and 3 form a linear pair. So how do you know they are a linear pair? Well, a linear pair is just formed by supplementary adjacent angles. You know they're going to be supplementary if they lie on a straight angle there. So yeah, by definition, angles 2 and 3 form a linear pair. So if we know that angles 2 and 3 are a linear pair, then what else do we know about a linear pair? We know that they're supplementary. And so how do you know they're supplementary? Well, that's just kind of by definition, right? So that, any angle in a linear pair, those are supplementary by definition. So once again, our reasons are just a couple of definitions. It doesn't have to be more complicated than that is the point I'm trying to get at here. So we've talked about angles 1 and 2 being supplementary, and that angles 2 and 3 would also be supplementary. So if angles 1 and 2 are supplementary and angles 2 and 3 would be supplementary, then that should be enough evidence to say that, angle 1 something, angle 2 is something else, but angle 3 would be the same something that angle 1 is, because they can only be 2 different angle measures in this here example. So angle 1 is going to be congruent to angle 3. How do you know they're congruent? Well, look, they're on the same side of the transversal. One's inside, one's outside. So that's the corresponding angle. They're corresponding angles right there. And what do we know about corresponding angles? We know that corresponding angles are congruent when they're in between parallel lines, right? And we know they have to be congruent because, like we just said before, angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle 3, so that would make angle 1 and 3 congruent to one another. So if these corresponding angles are congruent, which they are, that would prove that line L is parallel to line M. And that is because of the converse of corresponding angles postulate. So that's going to wrap it up for the notes. Thank you for watching. Sorry for running a bit long, but if you liked it, hit that like button. If you don't like it, well, don't hit that thumbs down button. That's going to hurt my feelings. Alright, bye everyone.